In this question, we have a long word problem that we need to translate into an equation that models the scenario described. And for this one, as we can see in the choices, we're going to need to create an exponential function. So first thing we'll do, let's write down our standard model, standard formula for an exponential that we see on the SAT. So P in this formula is the initial value of whatever it is you're measuring, or it's the y-intercept. R is the percent increase or decrease as a decimal. So if it's increasing, it'll be a plus here. If it's decreasing, it's a minus. And then T is the time, in whatever unit of time is given in the problem. So that's our standard formula. Now, when we read this question, we run into something that's a little unusual. It's this first sentence where they say the temperature of the cup of hot chocolate is being measured in a room with a constant temperature of 70. And so the upshot of this is this cup of hot chocolate, which starts at 185 degrees, will cool down. But it's only going to cool down to 70. It's not going to cool below the temperature of the room. And when we look at our formula for exponentials, there's not an obvious place where that idea should fit, right? There's no obvious place where there's going to be some sort of limit on how far this can cool. Like if you have a standard exponential function, it's just going to keep cooling until it hits zero, basically, or gets, arbitrarily close to zero. So how do we deal with that? And in general, when you're trying to come up with an equation, whether it's something complicated about the text or the choices look complicated or you're just not sure about how to build it, one option that can get you out of it that you can try is to plug in points. We're going to find points, values in the question, plug them into the choices and see which choice stands up to those tests. And then we'll be able to sidestep, at least sometimes, trying to figure out what's going on. Though I think it'll make sense once we come up with the answer, why the answer is what it is, when we kind of think about that orange highlighted condition. But let's start by finding some points. It says the temperature of the hot chocolate was 185 at 6 o'clock. So this is going to be some values we're going to plug in. Now they define T as the temperature, and they define M as the minutes after it started cooling, and it started cooling at 6 o'clock. So the point we can plug in here is our temperature is going to be 185 when our M is what? Well, M is defined as the minutes after it started cooling. It's starting to cool at 6, so this is where M is 0. And this actually tells us what the y-intercept may look like, but this is where we have to be careful, right? We might think, oh, this is like 185, so it should be A or B. But again, we kind of have this wrinkle with this orange highlighted bit. We may not quite fit this model perfectly, so let's not make any assumptions. Let's take this point, let's plug it into the choices and see what happens. So actually, for choice A and B, when I plug in M equals 0, these terms will drop out because anything to the 0 power is 1, and I get 185. So, okay, those can work. However, lucky for us, when I plug in M into choice C, this term becomes 1, and then 185 minus 70 is not 185, so we can get rid of C. And then choice D also works. When I plug in 0, this part of the term drops out, it becomes a 1, and then I'm left with 70 plus 115, which is 185. So I've got 3 choices that can work, no worries, we just plug in another point. Let's move on to the next one, which is right here. The temperature of the hot chocolate was 156 at 6:05. So that means the temperature is 156 when M is 5, because it's 5 minutes after it started cooling. So let's plug those in and test. So for choice A, 1.85 times 1.25 to the 5. Well, I don't even really need to put this into the calculator. You sure can if you'd like. I just know this is 185. This is not going to be smaller, right? It's supposed to become 156, and I'm going to be actually increasing this by 25% 5 times here. So I can plug it in, but yeah, it's not going to work. B could work though, so let's put that in our calculator. So it's 185 times 0.85 to the 5. At least that will be a decrease. So 185 times 0.85 to the 5. Okay, we get a decrease, but it's too small, right? We have 82 or so, 82 and change, and we want it to be 156. So it looks like B is going to fail. Hopefully D works. So let's try choice D. 70 plus 115 times 0.75, and then it's to the M over 5. So we have to do 5 over 5 here. So this is the same thing as 70 plus 115 times 0.75. And let's see what that would be. So 115 times 0.75 plus 70, we get 156.25, which is pretty close to what we were looking for. It's by far the closest out of all of them. So looks like the best answer here is D. And notice, we'll talk about what this equation means in a minute, but I don't really need to understand what these mean or why it's choice D versus A or B or C when I'm just using points. And that's the value of this approach. If you're having trouble with a question, having trouble sorting out what's going on in the word problem, just find values to plug in and test and see which choice works consistently with the points that you plug in. So this one gets us choice D. Now, what about trying to understand this one or generate the equation on our own without plugging in? I think it's a little challenging because, again, it's not really fitting our standard model here because there is this floor. There's this level below which the temperature will not decrease, basically. So, but I think we can still look at the choices and make sense of why at least some of them don't make sense and maybe why D does. You know, as we talked about with choice A, this is a increasing function, right? This is 1 plus 0.25 in that parenthesis, which means it's increasing by 25%, and we want our temperature to decrease. Now, B has that decrease, which is good. The only problem here, though, is there's nothing that's going to stop it from continuing to decrease, getting closer and closer and closer to 0. It's not hitting that minimum of 70 or approaching that minimum of 70. And that's why, even though, you know, it's got pieces that are, at least the 185 seems like it makes sense as like an initial value, it's not really working because, as we saw when we tested, it just doesn't work. But it doesn't have that floor, that bottom beyond which the temperature can't cool. C tries to be sneaky by throwing in this minus 70, so at least there looks like there's something that might try to take into account this minimum temperature. But if we just clean this up a little bit, if I just subtract 185 minus 70, we'll get this, and we'll realize this is really just the same thing as choice B, in the sense that, first off, this initial value is 115, which doesn't make sense. We know the y-intercept or the initial value should be 185. But when I plug in values, it's just not going to work, right? We already figured that out. This is also going to just decrease to 0 or closer and closer and closer to 0. It's not going to level off at 70. It's not, even though it's got the 70 in it, it's not doing what we want it to do. This leaves us with D. And again, it's not super obvious why you would do 70 plus this versus something else. Like, why is it 70 plus this term? I think one way to understand why this works, at least in the limit as m gets bigger and bigger and bigger, is as m gets bigger and bigger and bigger, again, this term, like it did for A, B, and C, will start approaching 0, which means as m gets bigger and bigger and bigger, the value of this temperature approaches 70. Here's your floor, right? You've got 70 as your starting point or your base, and then you've got this extra heat that's in the cup that's cooling, and that can go away, but we're going to ultimately flatten out to the 70. So this one might be actually hard to generate this on your own, but that's why we always have the choices for these kinds of questions. Whether we're plugging in or whether we're evaluating the logic of the choice, use the choices as information, right? Do that process of elimination, which can work pretty well on certain math questions, and that should lead you to choice D.